How is everybody? OK, you didn't all lose your voice from yesterday. That's good. Hopefully you've gotten enough caffeine. I need my second cup still. So I'm Julia. This is Writing Accessible Go. Before we get started, if anyone would prefer to read a transcript alongside the talk, you can access a preliminary one here. I will reconcile any differences later once the video is posted. So I'm Julia. I work for the Open Source Programs Office at Google. I build tools for folks at Google who write and use open source code. I joined this team a couple of years ago, and I was really excited because it was a Go shop, and I hadn't had the chance to learn Go. Before that, I had been basically using whatever I needed to do to get the job done, anything from C to Java to Python, and I had a very, very brief stint with Fortran a long time ago. I am also frequently described as stubborn, or more politely, persistent. And that came in very useful because shortly after I started to learn Go, my vision started to decline. And so I've been vision impaired kind of off and on since then. My eyes kind of look like an autofocus camera that can't figure out what to focus on. And that really delayed how I learned Go and prevented me from becoming proficient with it as fast as I could be. So I'm going to show you a very short simulation of what my eyes look like. If you are prone to motion sickness, you might want to look away. I will tell you when the slide is off screen. So it kind of looks like this. And I'll let this run for another cycle. OK, it is off the screen. Basically, what I have is a few spots of my eyes where things are in focus. And most of the time, it's all blurry. And what that means is that I have to take advantage of that small amount of time to glean as much information from what I am looking at as possible and work from memory the rest of the time. So we work in technology. We know that one of the worst things that can possibly happen to us is an intermittent failure. They suck. They make debugging a nightmare. And I was dealing with a biological intermittent failure. So I tried debugging. I got a beautiful, high-resolution screen. And it's gorgeous. It's on my desk. It's the envy of my office mate. But it doesn't do anything, sadly. I got fancy glasses from an ophthalmologist. They're basically what you can find at Walgreens. And they also do nothing, and they're gathering dust somewhere. And I played with my onboard system accessibility tools, high contrast, larger font sizes, et cetera. And that actually didn't help either, because the problem is actually in my brain, not in my eyes. So I kind of had to realize that I was, am, and probably always will be disabled. And that's a word that a lot of us are kind of uncomfortable with, and we don't hear a lot because it's highly personal. So let's demystify it a little bit. What is a disability? I could give you a lot of definitions and terms to look up later, but the World Health Organization has a great overarching definition here. It's when there's this gap between the capabilities of a person's body and the environment that they live in. It means that people who live with one or more disabilities have to work harder to do various things because their environment was built for somebody else. And it's not rare. 15% of the world currently lives with a disability. It's a pretty significant percentage if you think about it. So how does this apply to development? When we've got a new computer, or we have a new team, or a new project, the first thing we do is configure it. You get to choose everything, from the operating system to your IDE or editor, to how you're going to debug your code, to where you're deploying. How many of us know how well those various tools work with accessibility tooling? My guess is most of us don't. And if you think about how many different people write all of those different tools, accessibility isn't necessarily a priority for all of them the way it should be. So I want to show you a bit of a demo of using Mac OS's VoiceOver to navigate some very simple Go code. I won't go through the whole thing, but I'll get it started.
Package menu line. New line. Import left paren new line. Quote FMT quote new line. Right paren new line. New line. Type vector. Left bracket right bracket. Float 64 new line. New line. Func main left paren right paren. Left brace new line. Eta comma. B colon. Equals vector. Left brace 1 comma. 2 comma. 3 right brace. Comma. Vector. Left brace 4 comma. 5 comma. 6 right brace. New a comma. B comma. Underscore equals swap left paren a comma. B right paren new line. FMT period. Print left paren quote swap vectors a colon. Percent %v comma. B colon. Percent %v backslash n quote comma. A comma. B right paren new line.
So we got through 3 lines of code into the main function. There's still half the video to go, and I won't finish it. But it takes a lot of time to read through code, and this is actually higher than normal speed for VoiceOver. I also had to modify it to read punctuation. Most of the time, VoiceOver reads spoken language, which code is often not. And it turns out that if you don't pronounce a comma somewhere that's relevant for Go, and if you don't pronounce that colon equals, that's going to make debugging pretty hard. So as I was going through all of my research to figure out what tools I should be using and how I could work with code in an efficient way, it struck me that while I could find a lot of information on how to build accessible products, there was very little information on how to make developing itself accessible. How can I close that gap between the capabilities of my body and my environment, in this case, my development environment? And accessible tooling just isn't enough. I'm never going to be able to read code as rapidly with VoiceOver as I would like to. So here's some lessons that I've learned in the past 2 years. And a lot of these came from fighting for things in code reviews without actually realizing what I was fighting for. Now, a lot of these things aren't going to look revolutionary to you. They may already be practices that you're following, but my goal is to give you some extra context around them and give you extra reasons for following and prioritizing them. So I'm going to bring some of that code from the demo back up on screen. So I'm declaring 2 vectors, A and B. I'm going to perform a simple swap operation on them. Yes, I am swallowing errors. Then I'm going to declare another one, C, and add them all together. And I'm going to go ahead and say this is actually pretty OK code. It runs, at least, so that's good. It's always a step in the right direction. So this is 5 lines of code. I'm going to show you a functionally equivalent block of code. We're going to declare A, B, and C all together. We're going to go ahead and swap them and add them together. And this does not get my stamp of approval. It's 3 lines of code, though. Isn't that good? Why is the first one preferable? Well, when we declare A and B, right away, we're immediately making use of them. We're putting off declaring C until we actually need it. And this reduces the amount of context that you have to keep in your head before you get to where the variable is actually used. So you want to keep your variables close to where you actually make use of them. It does take a little bit longer to read than the 3 lines of code before, but it's all about reducing the amount of information that you have to keep track of. And the same goes for interfaces, structs, and types, et cetera. All of your code should be logically organized. Luckily, Go already asks us to keep things short. So my A and B vector are wonderfully named, right? They're short, they're easy to type, they're easy to listen to. Although you may have noticed that the screen reader pronounced A as so maybe I and J would be better variable names, actually. Doing something like vector A and vector B is not recommended. And you could say, Julia, I'm putting context in the variable name itself. I'm telling you ahead of time that these are vectors. That way, when they're used, there's no confusion. OK, that has like a little bit of merit. But it's redundant. If you're keeping your variables close to where they're used, this just adds extra information that you don't actually need. So short variable names are easy to listen to, and they're easier to navigate around. So that if you're working with, maybe you have difficulties with small motor control, this is really important. Or it's less effort to type, not just with a keyboard, but if you're using speech to text. Vector A is actually pretty hard to get speech to text to recognize. And you really do want to make them meaningful. So later down in my demo code, we added things together, and what we didn't get to was scaling the vector up. So I declare these two variables, total and scaled. They're both vectors. And that's OK. These are pretty meaningful names. I know right away how they're going to be used. Now, I have written this code before. I'm sure we all have, and I will probably write it again, to be honest. tvec and svec. You say, OK, well, T is for total, S is for scaled. But the thing is that when I see that, I don't actually know what T and S stand for. By using meaningful names, you reduce the cognitive load. You make sure that you're imbuing the variable name with what it does from the get-go. And it is a kind of light form of self-documenting code, kind of. I could put a comment above T and svec, or to the side, telling me what they are and how they're used. But guess what? That comment is an extra thing for the screen reader to read. It's an extra thing for me to navigate around. And we do want to reduce the amount of navigation that's necessary. If my variable name isn't meaningful, then I might have to go figure out where it's used and then go back to finish parsing the code. And that's a lot of extra work and a lot of extra time. Pronounceable names. I briefly toyed with showing you a screen reader reading not recommended code, and that didn't go well. So total is a great pronounceable variable name, as is function add. We know how to read those. We can say them. We can talk about them, as opposed to bringing back tvec or add all vex as a function name. And add all vex is actually pronounceable. You know what I'm saying. The screen reader can indeed read that. But it's not recommended. Concatenation poses some interesting issues. I was reviewing a pull request the other day. I reviewed them for the Go client library for GitHub. And I was using a screen reader. And it kept repeating this word, gthub, gthub. And I couldn't figure out what was going on. And it was getting in the way of me reviewing the core parts of the code, because my mind was just hung up on this one word. And you probably know what it is. It's GitHub. And it turns out that GitHub is not actually an English word, contrary to what we think. And moreover, T and H make a consonant. They make a sound. So that was a perfectly valid pronunciation of GitHub. So if you do use concatenation, you want to be very careful about the two letters that are concatenated in the words. So by using pronounceable names, you make it easier for people who are using screen readers. And it takes less time than pronouncing a string of letters. There have been times where I've been tempted to shorten up my variable names or function names by removing all the vowels. I don't do that anymore. And this is one of the reasons why. It takes a lot of time to pronounce. And it's just hard to figure out what's going on. So going back to the 5 lines of code versus 3 lines of code. Why is 5 lines better? Well, new lines are a very, very powerful tool. You want to use them like paragraph breaks. In prose, if you're reading something without paragraph breaks, you're probably lost. And if you read something that has tons of them, it's fragmented. The message also gets lost. You want to treat your new lines like paragraph breaks. I'm organizing my code by strategically putting a new line in between the 2 bits of functionality. But you don't want to use them too much, because the screen reader actually does pronounce the new line. So you want to use them sparingly and intentionally. I consider that blank line a line of code. And I'm sure some of you were thinking, that's actually only 4 lines of code. Where's this 5th one? That blank line has meaning to me. It guides me through the code base. It tells me things are changing. Now, the hardest thing that I have to tell people, this is the hardest thing to enforce, is consistency. Whatever styles that you pick, discuss them with your team early on, document them, and follow them. If you change styles midway through writing your code, I'm glad that you thought about changing your style, but you have to go back and update the rest of your code base. Because someone coming into your code isn't going to know that point at which you've decided to change your habits, your practices. So you do need to go back and update your code. And that's actually a really great place for new team members to come in and contribute. Keep enforcing them at code review times. One of the great things that I really appreciate about how we write Go at Google is that a lot of the things that we look for at code review times are documented. And so when I get feedback on my code, they send me links to what style I am violating. And those links are really informative, and they help me. And this is a way that you can help folks adhere to the styles at code review time. So you may be saying, OK, I don't have any developers right now that on my team that are living with a disability. Can I just not consider any of this? And the answer here is, probably unsurprisingly, no. And that's because not all disability is visible. I've seen a lot of you during the conference, and you probably don't know that most of the time I have to use a variety of tools to actually read my code. I have to touch the wall to navigate around at times. So you don't know what a person is dealing with just by looking at them. And it's also not an on or off thing. Disability isn't necessarily a permanent state. You can be temporarily disabled, like if you break your arm. You're not going to be able to write code as rapidly. So people transition in and out of states of disability, and capabilities do vary day by day. There are some days I can churn out code, and I take advantage of those. And there are some days I can't look at my screen. You just don't know ahead of time. And finally, accessibility helps everyone, especially on an open source project, especially on a team that has a large code base. So there's something called the curb cut effect. This is a pretty well-known phenomenon. Cities when they were trying to make their streets more accessible to wheelchair users, they put these curb cuts, which are ramps between the street and the sidewalk. And an unexpected thing happened here. They found out that putting in these curb cuts made the city more navigable by parents and by tourists. I believe it actually increased tourism in these cities. So the curb cut effect is when something built or designed for one population winds up helping others outside of that population as well. And these practices that I've described, that hopefully you're already following, are code curb cuts, which is actually incredibly hard to say. So these practices make your code more maintainable. They make it more logical, more readable. And that doesn't just help people living with disabilities. That helps everyone. It makes for a better onboarding experience because your code is more parsable. It helps new engineers and senior engineers alike. And that's a great thing to add to your code base. And it does make for a more inclusive environment. Thinking about these things up front helps out when you've got people considering joining the team, considering contributing to your open source project, et cetera. So, the 3 notes for writing accessible Go. Organize your code logically. Be very intentional about your new lines. Keep things close to where they're being used. Make things pronounceable. Be very cautious with concatenation. And be consistent. Consistency is really easy for everyone, right? So that one should be no problem. So if you want more information, here's that transcript again. There was a great talk at PyCon this past year about Python code style for blind programmers. I highly recommend you watch that. If you are an Emacs user, like me, there is an Emacs plugin that's called Emacs Speak. It was built by a longtime Googler, TV Raman, and it does text-to-speech for Emacs. And one of the links that I found very helpful was this Tools of a Blind Programmer piece, which is more of a treatise than a blog post. And if you want to hear more about curb cuts, here's a link to a podcast. So I'm Julia. Feel free to come talk to me after the talk during breaks, and I'm happy to answer questions or get tips, both of those things. So thank you.